record, and I'm going to start share screen. Okay, need to get to the point that we discussed yesterday. Okay, yeah. Okay, then. Okay, so yesterday we discussed data pre-processing. If you recall. Okay, so for data pre-processing, generally speaking, we just hold on, I need to wear this. So we need some techniques, we call it imputing, is it, to deal with missing data. Missing data, is it? So that's the strategy we do imputing. Is it basically it's interpolation, is it? And one of the interpolation with mean is a column mean. Basically, it's a feature mean. So specific feature means that's one of the commonly used technique to deal with missing data. Okay, and then we also discussed regularization. That regularization will help with overfitting. And who still remember the parameter in sklearn to do the regularization so far we have learned? So do you still remember? That's that C, is it? The parameter C, okay. And basically it's the lambda, is it? So it's the inverse of lambda. Okay, so that's regarding regularization. And then we also discussed feature selection. Feature selection is also quite important, is it? Why it's not, why I cannot write? So feature selection. Okay, feature selection. And one of the technique we already learned is through the features importance, is it? Feature importance attribute, is it, in the model? Then that attribute will give you of the importance of the feature, is it? And then you can sort and you can pick the top number of the important features, is it? So that's feature importance. And then let's just do a, yesterday I remember we already started this wine example, is it? So there are 3 types of wine. So this is for classification. And based on the provided features, is alcohol, malic acid, ash, and magnesium, is it of this listed features, is it color intensity? So based on the feature, then you can classify the wine as class 1, class 2, or class 3, is it? So that's regarding this example, and we didn't finish it, is it? And I remember we already discussed this. This is pretty straightforward, is it? Test and train split. And we also discussed data standardization. So this is also belong to data pre-processing, is it? So data pre-processing, we just discussed missing data imputing, and then regarding feature, we can do feature importance and regularization, is it? The third one is to bring data, is it? It's regarding features, is it? Features into same scale, is it? because otherwise when we apply machine learning model, it's not efficient, is it? And yesterday we also discussed there are two approaches overall. One is called normalization. So normalization is you use minimum and the maximum, okay, to do normalization. And the value is going to be between 0 and 1, etc. And the other one is a standardization. And standardization use mean, etc., and the standard deviation, etc. And this helps more for you remember outlier. Outlier, it will bring outliers, etc. Hold on, let me get. So that's about bring data into the same scale, so that we can do the model training. So that's regarding that. And in sklearn, we can directly import maxim scalar and standard scalar, and just remember, you need to transform data first, okay? You need to transform the data. So that's why over here we have not just train, so you are going to have train normal, or you're going to have train standardization data. Then you're going to use those data to fit your model. So here we are going to use the logistic regression. Oh, and then regarding regularization, remember yesterday we discussed there are two, L1 and L2, etc. And L1 is what? Is sigma absolute Wi, etc. L2 is regarding what? Is sigma and Wi square, etc. And we don't need the absolute, it's the square, etc. And the the L1 can help in feature selection, you remember? In feature selection, etc. Because you remember that diagram that we see, etc. So we have the contour, etc. So this is the cost function's minimum point, etc. And regarding the regarding the so here's the contour, and regarding that L1, etc. So this is L1, etc. So the intersection point is this is W2, this is W1, etc. And then in this case, etc. W1 can be 0, etc. So that's why over here we said W1 can help in feature selection, etc. Because it can lead to some weights be 0, is it? So that's why we said we can have sparse, is it? The feature distribution is going to be sparse. Sparse means some weights going to be 0, is it? And if the weights is 0 in your training, then definitely you can drop that feature, is it? That's why we say L1 help in feature selection, is it? And on the contrast about L2, and L2's goal is to train that parameter C. So basically it's that lambda, inverse of lambda. Is it because you are going to add, so this serves as what? Serves as penalize certain weights. Is it? Certain weights. Okay, so that certain weights won't take a higher share, is it? And because of this, so it won't lead to that sparse scenario, is it? So that's why, generally speaking, this L2 helps in overfitting, dealing with overfitting. Okay, so that's the general idea about data pre-processing. Okay, So anyway, so that's why over here you specify, okay, penalty is L1. Okay, so that means I want to use L1 to regularization, okay? And there is another name for L1 and L2 regularization. So L1 is also called lasso. So if you read some articles at lasso, then you know, okay, it's L1 regularization. For L2, it's also called ridge regularization, okay? And so in this logistic regression, that we also specify C, that and the penalty, that, and in sklearn help us directly provide us a model called select model, and it's from feature selection. That so you can use this select model that you specify which learning algorithm you want to plug in, is it? And plus also you can specify the regularization attribute, is it? Okay, and because of this select model, is that you may say, oh, why do we need to use it? Is it because it can provide a lot of helping information for feature selection, is it? Because this is from feature selection. This is helping in regarding select feature, is it? So how do we get information about importance of feature, is it? So with the select model after you do train, is it? If you call this method get support method, is it? And it will return what? It will return a true false list, is it? An array, is it? True false an array. And if this corresponding feature list as false, then that means its importance is less than the mean importance. Okay, mean importance. So it's not that important. Okay, it's not. So through this get support, so this kind of serves as a filtering tool, okay? So give you idea which feature is important and which feature is not important. And you can also get the coefficient, is it, of your model, is it? And over here we said why we have 3 rows, is it, of the coefficient. It's because over here we have 3 classes. Okay, so that's why we have 3 set of coefficient. And through this coefficient, you can also see it because if it's 0, that means it didn't play any role, is it? And because of that get support, is it? Get support tells you true false, is it? So basically this get support, it gives us true or false, is it? For certain feature. Is a certain feature. And here feature means a column. Is it in our data set? In the data set, is it? So through this, if we use this list comprehension, is it list comprehension, then it says, okay, if that feature is true, I'm going to keep it, is it? I will record its index. So record its index. This we already know, this is list comprehension, is it? In Python previously at the beginning of the class, we learned, is it? And then over here, you said, okay, for the training data, I'm going to use only those features, is it? Those true, listed as true, importance as truth feature, is it? So what you can do is, okay, you select off the data, is it? But over here, you have selected columns. Selected columns. That's how we can do this, is it? Okay, and then over here, it lists, is it total features? Okay, total feature is the original training data, is it? And then if you want to know how many you got selected, is it, this is the selected feature, is it? So you can get its number using length, is it? And over here, here also, if we apply NumPy, this is broadcasting rule. This you don't need to do one by one check, is it? So you apply this array and equals to false. It will list, it will get all of the false ones, is it? And then sum them up, is it? So that's how we know, okay, there are 3 coefficients shrink to 0, is it? Okay, so that's the idea about this part. And then over here, it also shows, okay, you can also specifically find all 0 columns over here, it says, okay. So what is this B, is it? This B is you get that coefficient. Remember, we can get the coefficient, is it? And for that coefficient, then you want to know who is 0, is it? And if it's 0, and you can record its index, and we use that argware, is it? This is also quite useful, is it, to do filtering, argware, so that you know the index, you can get the index. Previously, we also learned that argmax, is it? So this is argware, okay, also quite useful. Okay, so you can specifically know which column, which feature basically didn't contribute any row, is it? And then what next we can do is over here. What it shows us is because you can, the column indices, is it, is that, so the feature importance is 0, is it? The indices, so their index basically, is it? The column index, is it? So if from the training data, is it, you get all of their indexes, is it? Then you will know, okay, what those 3 features are specifically, is it? So here to also list what are those 3 features, okay? So here it's just to deal with how you get all of the detailed information when you do feature selection, is it? What next? Let's see. Over here, we use logistic regression. Okay, logistic can be used for classification. Okay, you said I'm going to L1. This is L1 regularization, is it? And this is the regularization coefficient C, is it? And then you do the training, and then you can get the training score and the test score, is it? And you can see the result is quite good, okay? But this is unfiltered, okay? So this is using all features, okay? Didn't filter out, okay, anything. Okay, and you can also get intercept, because here we have 3 class, okay? That's why we have 3 intercepts, okay? And then you can also find if the coefficient is not 0, is it how many of you have, is it? And here to list the detail about the coefficient, okay? So sometimes you want to get some more detailed information, okay? And what the next part showed us is regarding the relationship, okay, between, so we are going to see how this regularization, is it? Regularization parameter, is it contribute to the weights, okay, to the weights. That's what this part mean, okay. And over here, because totally, I remember there are 13 features, okay. 13 features. Because if you have some drawing like plotting like this, you will have some better idea, okay. So over here, we have 2 lists, weights and parameters. the initiate as empty, okay, to empty list. And then here is a loop, okay, loop in certain range is a -4 to 6, okay. And then for this penalty, we still use L1, etc. But for C, you see, the value is going to change, etc. So it's going to change from, so 10 to the C, etc. So that's what the range is going to be. So basically, it's going to range from 0, 0.1, etc. to 10 to the 6, something like this, the C's range, etc. And the lambda, then it's a corresponding inverse of it, okay, in logistic regression. And then we do logistic regression training, etc., training. And then we are going to pick the second class coefficient, etc., the coefficient, and add it to the weights, okay, add it to the weights. And then let's see what it reflects, okay. And then you are going to plot, is it? Plot the relationship between the weights, is it? And the C relationship, okay. So let's see. So this is a diagram to show, is it? So over here, is it for different color? You can say it's for different feature, is it? So for each of the feature, so this diagram reflects each feature's relationship, is it, versus what it's the C, is it, versus C. So C can change from this kind of range, is it? And you can see kind of when C is 0.1, is it? So all of them don't contribute because the weight coefficients almost 0, is it? But starting at 1, is it? You can see each feature, the contribution is different, is it? The contribution is different. And the higher, and for the C, is it? Looks like the weight contribution described more, is it? So some feature contribute a lot and some feature contribute very little, is it? But this doesn't mean this is a best scenario, okay? So you also need to take a look at the accuracy, is it? Because when we analyze a model's performance, is it? Accuracy, is it? Is one aspect, is it? We also learn confusion matrix, is it? And we also learn that precision, is it? Recall, and F1 score, is it? So all of those, is it? So we need to combine of them when we analyze the performance, okay? So this, but anyway, from this plotting, you can clearly see the relationship, is it, between C and the weight coefficient, is it? So when C changes, the weight coefficient also changing, is it? So that means it contributes differently, okay? So that's what this plotting try to show us, okay? So then next, let's see. And this example also gave us, it's called, how do we select features? This is the sequential feature select, but this is not from sklearn, okay, sklearn. So it's just each time you pick a certain number of features, is it? And then you are going to collect the accuracy score, okay? And then you can compare and find the best performance subset of the features. That's what this sequential best feature selection, okay, algorithm does. And then we can we can kind of use that to get some idea, okay? So what next we are going to do is with KNN learning model, okay? And we just use 5 neighbors, okay, 5 neighbors. And then here it says we are going to do feature selection, okay, feature selection. And so we are going to plug in with that model with KNN, is it? And the initial feature, is it? It's 1, is it? Then we do the fit, is it? Do the fit. And we can collect the subset of the features, okay? So 1 feature, 2 features, 3 features, 4 features, something like that, is it? So, and then we can do some plotting, is it? So number of features versus accuracy, is it? That's what this plotting shows us, is it? And you can see, is it? So when it reaches a certain number, is it? And if you increase the number of features, decrease, is it? But when you go up, pick more features, is it? At a certain point, it's kind of no change for the accuracy, is it? So a lot of time you need to do this kind of plotting, okay? This kind of plotting can also help you to determine the optimum number. So optimal number of features. Okay, so that's what this plotting trying to do, okay? And you can also, so this lists all of the features, is it? And what that sequential selection, feature selection does is it gives you the subsets, is it? And list the importance of the subset. And you can clearly see, is it over here says, okay, the first feature is very important, is it? Then over here it says, okay, the first and the 12th feature are important, is it? And this is tells, okay, the first feature, second feature, and the 12th feature are important, is it? And if you include every feature, then over here to list all of the features, is it? So it gives you the subset of the importance, okay? And over here is that this K3 is what? Is from the tense, is it? The tense. So this is sub-0, is it? So this is sub-0, is it? And this is sub-12, is it? Sub-11, is it? So that's regarding this sub-10. Is it? So I want to select from this subset, is it? So you can retrieve this subset. So that's what this part does. So retrieve a subset of features, is it? From this feature selection results, is it? And then you can see the columns, is it? What is the column? Oh, it says it's alcohol, acid, and this. It lists these 3 are important, is it? And for this training, and this is still the original data set, okay? Not with reduced features. So we use the KNN as to do fitting, and then we collect the training and the testing score, is it? And you can see the training and testing around 96-ish, is it? And what next one shows, is it? So over here, did you see when you do the training, is it? So I use only selected features. Is it? I only use select. I didn't include all of the features, only selected features. Is it? And I apply for the KNN. Is it? And then I collect the score. Is it? And you can see the score decrease a little bit. Is it? But still 90%-ish. Is it? So not too bad. Is it? Not too bad. So that tells us about feature selection. Okay. Okay, so that's regarding feature selection. And what next shows us, previous example, we also discussed this, okay. Assessing feature importance with random forest. So here we use that random forest a model, and then we do the training. After you do the training, so this is the important part. So you can collect the feature importance. This attribute? This attribute will give us the importance scale of a feature. Okay, so all of the feature importance will be listed out. And you can also do arc sort. Arc sort. So this is going to be reverse order. So it will be in decreasing order. Descendant order. And then we can print off them out. The name of the feature and its importance? We can also do bar drawing, okay, of its importance. Of its importance, okay. So what the next one shows us is, so after we collect that, it lists of the importance of the feature, and from the value you can see, this is around 20-ish, percent, and this is just 0. So basically it's 1%. Contribution to the importance of the model? That's why if you get rid of that, that won't hurt a lot of your model, and the bar drawing also clearly shows. So with this visualization, you can clearly find out the importance of the features. Yeah. So that's regarding all of this feature importance selection, okay. And then what next one shows is in sklearn, you can, for feature selection, you can also use this model, select from model. Okay, we can also do this. And for this select from model, you can define a threshold. Okay, so what this threshold means, if the importance is greater than, in this case, 10%, 0.1. Then I'm going to keep that feature, okay? Otherwise, I'm going to discard the feature, okay? But for this select from model, for this module, you need to import the model, okay? So this is an imported model. And you already trained that. You already did the fit of that. Oh no, I'm sorry. You already did the. You already initialized that forest. So this is the random forest model. Okay, so you need to import the learning model. Learning model object. Okay? And then you can plug in your training data, X training, and you call the transform, and this X selected, this will only be the data set, so data set with selected features. Okay, so all of those that's less than, the importance less than 0.1 are thrown away. thrown away. Okay, so that's what this part means, X selected. Okay, X selected. And over next one, and you can also see, okay, it will tell you, is a certain kind of data, is it also thrown away, didn't meet this criteria, okay? And features that meet this criteria, in this case, we only have 5 features meet that criteria, is it? And you can also see what are the 5 features, the 5 features. And what next I did is, then I use the selected feature set, is it, to do the random forest training, is it? Then I'm going to collect the score, is it? And you can see in this case, is it, for training, the accuracy is quite good, is it? But for testing data, is it, the accuracy dropped a lot, is it? So this is definitely not a good selection, is it? But it just shows you, is it, how do we do feature selection, is it? Okay, this is for random forest case. Then same thing, you can apply KNN, is it, for only selected features, is it, only selected feature. And then you can also collect this, the accuracy score, and you can see it's not good. Okay, it's really not good. That means this threshold is not a good choice, is it? So if you want to improve your model's performance, then you need to find the best, the optimal threshold. Okay, threshold. Okay, so we finish this example. Okay, so basically we are also